there people here right now? Hello? Alright, so I guess I'll just do this question. So, I'm assuming this is from like your class. So we're given a graph of velocity and we're asked to answer these 9 questions. Okay, so it looks like, just looking at the graph, real quick, it looks like that the velocity function is made up of a bunch of like lines, right? Which is nice, because lines are pretty simple. So if we have s of 0 is equal to 4, what is s of 3? So the idea is s is position, right? So position is going to be the integral of velocity. So in this case, we can just take the area under the curve. So the idea is s of 3 is going to be our initial position plus, that's not a plus, plus the integral from 0 to 3 of our velocity function. The reason here is because if we take the integral of the velocity function from 0 to 3, that doesn't actually give us the position at 3, it gives us the change from 0 to 3. So the change in position from time equals 0 to time equals 3. So when you do this, you know s of 0 is 4. And then to find this integral, we just take the area under it, right? So here we have a triangle with a base of 1, a height of 2. So that's going to be 1/2 of 1 times 2. And then we have a rectangle here, which is also 1 and 2. And then we have another triangle here, which is 1/2 of 1 and 2. So that looks like it's going to be 4 plus 1 is 5, plus 2 is 7, plus 1 is 8. So that's going to be 8 here as our answer. I'm just going to, I think, just fill in the areas here. Just call this 1, 2, 1, and then I'm just going to do this here, where I have, if this is 4 and -2, that's going to be -1, -2, and this area here is going to be what? That's going to be -2 plus a half, right? So that's going to be, or -2 minus a half, I mean. So that's going to be -2.5. This here is a 3 and a 1, so that's going to be 1.5. And this here is, it's unlabeled, so I can't really tell, because if I draw a horizontal line, I'm assuming that's a 2. So, I don't know, just bad drawing. Hello. So this one, I think I'm just, I really don't know what to assume this point to be. Maybe we say 8, 2, so under that assumption, this area is going to be 1 here. Alright, just labeling the areas for the different sections, because for number 2, it says, when is it furthest to the left? So here, the areas are all positive, right? So what does that mean? That means it's moving to the right. So that means by the time it hits 3, it's going to be 4 plus these here. So that means 1 plus 2 plus 1 is 4. So that moves 4 to the right at 3. But at point 3, it starts to turn around, right? Because velocity is negative, and negative velocity means it's moving to the left. And it moves left all of this amount. And you can see this area is bigger than this upper area here. So that means it's going to be furthest to the left at time equals 7. Whatever the units are. The location is going to be s of 3, which we already know, right? We found that from part 1, so I'm just going to use it again. But then plus integral from 3 to 7 of v of t dt. So this tells us what is the change in position from time equals 3 to time equals 7. Then s equals 3 is going to be 8, like we said. And then here, this area is going to be -1, -2, -2.5, -1.5. This here makes -4, so that's -7. That's going to be a position of 1. Any questions so far on the first two? Okay, number 3, average acceleration for 0 to 8. So anytime they ask you for average rate of change, right? Acceleration is the rate of change of the velocity. We're just going to be looking at the slope using, or slope of the points from 0 and 8. So the slope is going to be the velocity when it's time equals 8 minus the velocity when it's time equals 0 over 8 minus 0, of course, right? This is the slope formula. Again, I'm assuming from the picture that it's a 2. It could be a 1 though, because it's like kind of not that cleanly drawn. But if it's 2, then it's going to be 2 minus 0 over 8. That's just 1/4. If instead of average acceleration, it says instantaneous acceleration for some time, like instead of giving a time interval, it said like time is equal to 4, for example, then you would just find the slope of this, the instantaneous slope, when time is equal to 4. But anytime it says average, then that's just the slope of a secant line. Next, average velocity for this interval. So the difference between number 3 and number 4 is obviously number 3 is asking for acceleration and 4 is asking for velocity. So here, for acceleration, since acceleration is the rate of change of velocity, we just use slope, but we can't use slope for number 4 then, right? Because velocity, we're given velocity here. So instead we need to use the average value formula, which if you remember is going to be, by the way, this bar here is a common notation used for average, or you can also write like V average, whatever you like. But the formula is 1 over 8 minus 0, integral from 0 to 8 of our velocity. And just plug in our numbers, 1 over 8. Our area from 0 to 8 is going to be all of these numbers that I have added up, right? 1 plus 2 plus 1 minus 2. And so on. So these cancel. This is minus 4 plus 2, that's minus 2. That's going to be 1/8 times minus 2, which is negative 1/4. So the average value of the velocity over this entire interval from 0 to 8 is going to be negative 1/4. Number 5, what is a of 3? Well, a of 3 is just going to be the slope of the tangent line when t is equal to 3. That one's pretty easy because we just use the slope of that line here, right? Because a tangent line to a line is just going to be the line itself. So maybe I'll just do that at the bottom here. So I can just use the endpoints here. I can use this endpoint up at the top and this endpoint down here. That's going to be what? So we have -2 minus 2, and just write it without parentheses, over 4 minus 2. And that's -4 over 2. That's going to be -2. Number 6, when is the acceleration 0? So acceleration is 0 anytime the tangent line is going to be horizontal. And that's in several places here, right? That's from this location and this location here. So we would say from 1 to 2. I have to have open parentheses here because technically derivative is not defined at 1 and 2 because it's a sharp turn. And also that'll be 4 and 5. What is the greatest acceleration? So the greatest acceleration is going to be the largest slope of the line. That's going to be here, right? That's the steepest part. So if I use those points, those are going to be 7, 0 and 6, -3. So the largest acceleration is going to be 0 minus -3 over 7 minus 6. That's going to be +3. And then number 8, what is the greatest speed? Speed is the absolute value of velocity. And the largest speed is going to be the absolute value of -3, which is +3. And that's it for this problem. All right, any other questions? Did I skip 7? Oh, yeah. Thank you. Okay, so let's do 7 here. When is the acceleration undefined? Undefined is when the first derivative is undefined, right? So first derivative is going to be undefined at each of these corners. And technically the endpoints as well, right? Because the definition of derivative means the limit as the derivative as from the left side must equal the right side. Yeah, so we can just say all of those corners. So we can say it's a set of values including 0, 1, 2, 4, 5, 6, 7, 8. Only one that's not is 3 because 3 is like part of a straight line. All right, any other questions you guys want me to do? If it was decelerating with slope -4, it wouldn't be the greatest acceleration, right? Yeah, because greatest is assuming like that it's positive, I guess. Just to clarify, right? There's nothing here that has a acceleration of 4, but you're just saying like hypothetically, right? So like if like the way the question would have to be worded for that to be the greatest acceleration would have to be asking you for the greatest magnitude of the acceleration. So magnitude is ignoring the like sign of it, like the positive or negative. Yeah. So it's possible for the like the largest negative one to be the answer as long as it's asking you for like the magnitude of it. Just like how like speed is the magnitude of velocity, so when you're looking at speed, you just ignore the direction, so you ignore the positive or the negative. Alright, if there's no other questions, I think what I can do is, I mean, rather than just sitting here, I might as well do something, right? So I think I'm just gonna do some practice questions from College Board's website. If you have questions, then I'll just do those instead of doing these, but in the meantime, I'll do these, and you can find it at this link here. I'm just going to do the 2010 questions. Oops, not that. Okay. So first, this question is part of the... Actually, this is a calculator question. Maybe I'll just do the no calculator question since your test tomorrow is no calculators. So that would be number 4. All right. So it says let R be the region in the first quadrant bounded by the graph of y is equal to 2 square root of x, the horizontal line y is equal to 6, and the y-axis as shown in the figure above. Then they want us to find the area of R. So how can we do that? So area, normally you would just do the top minus the bottom one. I think that's fine here, right? There's no reason not to do the top one minus the bottom one. So let's go ahead and do that. So we know the left bound is going to be x is equal to 0, the right one's going to be at 9, so we just have area of r is going to be integral from 0 to 9. The top function is going to be that 6 here, and the bottom function is going to be that 2 squared of x. And we just write dx here, right? And just integrate this. So that's 6x. This is minus 2. This is a 1/2, so I make that a 3/2 power. And then I multiply by 2/3, so that's going to be 4/3 here. And then value that from 0 to 9. And what is that? If I plug in 0 here, everything becomes 0, right? So all I have to do is just plug in 9. That's going to be 6 times 9 minus 4/3 times the square root of 9 to the 3rd power. That's the 3/2 power, right? That's 54 minus 4/3 times 27. Because 3 to the 3rd power is 27, so that's 936. 54 minus 36 is 18. Answer here is area is 18. All right, next we have it says write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y is equal to 7. All right, so here we're going to have this is a not a disc but a washer, right? But technically they're like really the same thing. So to set up the volume, what do we have to do? So first we're rotating around a horizontal line, so our bounds of integration are going to be the same, right? We multiply by a pi here because the formula is pi r squared. So first we're going to do the larger radius, right? And that's going to be, since y is equal to 7 is up here somewhere, the larger radius is going to be to the bottom function, right? So that's going to be 7 minus 2 rad x, and we square that, and then minus, and then the smaller one is going to be 7 minus 6 squared. And this is the formula, right? Just as a refresher, formula is like this. Where you have the big radius squared minus the small radius squared, dx. So then how do we integrate this? Actually, it doesn't even ask us to, right? It's just do not evaluate. So all we have to do is just write it. So this whole thing is going to be our answer. But if you were to integrate this, all you would have to do is just expand this. And then you can integrate each term separately. All right, then we have part C. Which is like this. So region R is the base of a solid. For each y, where y is between 0 and 6, the cross section of the solid taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base. Right, but do not evaluate an integral expression that gives the volume of the solid. Okay, so we have a region that looks like this. We have our square root function, we have our 6. The point was 9, 6, right? Yeah. So what they're saying is we have y values from 0 to 6, so that's here, 0 to 6. And the cross-section of the solid taken perpendicular to the y-axis is a rectangle. So we have a rectangle where this is the base of the rectangle, and the height is 3 times the base. It's gonna be like, I can't really draw the third dimension the way I'm doing it here. Maybe I can draw like coming out of the paper like this. So the idea is I have some x value here, right? So this is going to be the x value of this coordinate, which is going to be given by x, and the function was y is equal to 2 squared of x, right? So this like f of x or something. And then the height of this rectangle that's coming out of the paper is going to be 3 times that. And then we're going to do that for all of the x values or y values from 0 to 6. So if I'm integrating from 0 to 6, then I have to have something like this, right? V is equal to integral from 0 to 6 of something and then times dy. So my function here is going to be this function, this f of x function, but I need to write it in terms of y. So my function is y is equal to 2 squared of x right now. Write it in terms of y by dividing both sides by 2. And square both sides, x is equal to y squared over 4. Okay, so this base then of my rectangle is going to be, instead of calling that x, it's going to be y squared over 4. And then the height of the rectangle is going to be 3 times y squared over 4. So those are the dimensions of my rectangle, and I need to do that for all of the y values. Formula becomes just multiply the 2 together, because that's how you get area of a rectangle. Like this. You can even write it so that 3 and 16 come out just a little bit nicer. And it doesn't ask us to evaluate that, right? But although it wouldn't be hard to evaluate this. They just wanted to set it up. Any questions with this one? So this problem, as you can see, is really testing whether you understand areas, volumes, like the disc and washer method, or this cross-section technique. All right. Looks like there's not any more questions, so I'm just going to continue with this then. Just do number 5. So number 5 says the function g is defined and differentiable on this closed interval and satisfies g0 is equal to 5. The graph of the first derivative of g is given, and it consists of a semicircle and 3 line segments as shown in the figure above. Find g of 3 and g of negative 2. Okay, so how do we do this? This is pretty much the same as the first question that I just did today, right? Or the first set of questions, where g of 3 is going to be the initial value, g of 0, plus the integral from 0 to 3 of the first derivative. We're not given the first derivative function, but we're given the graph, so we could just find the area under the curve. G of 0 we know is 5. We add 0 to 3. Well, 0 to 3, first we have this quarter of a circle, right? So that's from 0 to 2, so it's a quarter of a circle. So it's 1/4 pi r squared, where r is going to be 2 here. And then plus this triangle, which is going to be 1/2. The base here is 1, the height is 3. And just add those values together. That's going to be 5 plus 3/2 is 6.5. And then plus pi. And we can just leave it like that. Because it's no calculator, right? So we don't need to change it to decimal. Next we have g of negative 2. It's the same idea, right? We're going to have g of 0 plus integral from 0 to negative 2 g prime of x dx. When I write it like this, you should probably notice that these are out of order, right? So a property of the definite integral is you can flip it around if the whole thing becomes negative. Because the property I'm using here is integral of, or from b to a of just any function is equal to the negative of the integral from a to b. So when you flip the bounds, you have to take the negative of the whole thing. And the reason why I'm going to put in the effort to make it negative of this is because this way, this is exactly the area that we see in our graph, right? So there's no confusion about that. So what is that area? Well, that area is also a quarter of a circle, right? Because it's just exactly this area from negative 2 to 0. So that's going to be 5 plus a quarter of pi times r squared, which is going to be 5 plus pi. Oh, sorry, it's a minus, right? Because I wrote a minus earlier, so it's 5 minus pi. All right. Any questions on that? It's very similar to the ones that I did earlier today. Okay, next it says find the x-coordinate of each point of inflection of the graph of y is equal to g of x on the interval -7 is less than x is less than 5. So from -7 to 5, explain the reasoning. So we want to find x-coordinate of the inflection points. And the inflection points are going to be when the second derivative, in this case our function is g, so when the second derivative changes signs. Right, it's not enough for the second derivative just to be equal to 0. It has to be 0 and it changes from negative to positive or positive to negative. We're given a graph of the first derivative, right? So the second derivative is really just the first derivative of what we're given, g prime of x, right? So if we are looking for the first derivative of g prime of x and we're looking for when that changes signs, then effectively all we have to look at is when does g prime of x switch from decreasing to increasing, or the other way around, or increasing to decreasing. Right? Because the first derivative tells us when the function is increasing or decreasing, right? So if the first derivative needs to change signs, that's going to be changing from increasing to decreasing. Increasing is a positive first derivative. Decreasing is a negative first derivative. So when does that happen? The function changes from increasing to decreasing here at 0, because you can see it's increasing here and then it starts to decrease after. At 2, it goes from decreasing to increasing. And then at 3, it goes from increasing to decreasing. Okay. That's pretty much it. So we're going to say at x equals 0, 2, and 3. So normally when we're looking at points of inflection, we want to look at the second derivative. So you need to take the derivative twice. But in this case, we're given the graph of the first derivative, so I only need to look at the first derivative of my graph, because the first derivative of the first derivative is the second derivative of the function. A little bit confusing, but I think shouldn't be too hard to grasp. Questions on this one? Alright, next. Function h is defined by h of x is equal to g of x minus 1/2 of x squared. Find the x coordinate of each critical point of h, where it's between -7 and 5. So that's the endpoints of our graph. And classify each critical point as the location of a relative minimum, relative maximum, or neither a minimum nor maximum. Explain your reasoning. Okay, so we're looking for critical points, and critical points are when the first derivative, so that's going to be h prime of x is equal to 0, right? So why don't I go ahead and find the formula for h prime of x? So they give me h of x is equal to g of x minus 1/2 of x squared, right? So if I'm taking the first derivative with respect to x, well, I just need to take the derivative of everything that I see, everything that's given in terms of x. First derivative of g of x in terms of x is going to be g prime of x. And then first derivative of 1/2 x squared is just going to be negative x, right? And then you need to set this to equal to 0. And any x value that satisfies this is going to be a critical point, right? So I simplify this, I can say just whenever g prime of x is equal to x. So when does the first derivative equal x? That's going to be in two different places, right? That's when I intersect this line. This is the line where y is equal to x. And you're going to see there's one here and one here, right? That's when the y value is equal to the x value. What is that? This one is really easy to see. The one that I've circled up at the top is going to be 3, 3, right? But for this one, it's not labeled, so I need to go ahead and solve for that, right? I know this is a circle with a radius of 2 that is centered at the origin, right? So that's going to be for this semicircle, that's going to be g prime of x is equal to, if I have a centered at the origin with a radius of 2, that's going to be square root of 4 minus x squared. So if I solve this and I say x is equal to that, and I just solve for the x value, that's going to be x squared is equal to 4 minus x squared. 2x squared is equal to 4. X squared is equal to 2. X is equal to plus or minus rad 2. But you can see in our picture, it's only the positive one, right? So the critical point here is only going to be x is equal to rad 2. So we have two critical points. We have x is equal to rad 2, and we have x is equal to 3. Then we need to see, is it going to be a relative minimum, relative maximum, or neither, right? And how do we do that? Well, normally what we do is we create a sign graph for the function, right? So let's see if we can do that. Sign graph for h prime of x. So our h prime of x is given by this one, which is equal to g prime of x minus x. Alright, so here it might even be helpful, or you might see why it's helpful for me to draw the line y is equal to x, because this dashed line that I have here, right, is going to be the line of y is equal to x, and the solid line that they've given me, of course, is just g prime of x. So g prime of x is going to be, so g prime of x minus x, let me just write it in a different color, is positive when g prime of x is greater than x, right? And when is g prime of x greater than x? That's going to be here, because this is above this dashed portion, right? So we can say, actually it's for the entire left side, right? But I mean, we only really care about a small set of values. So if these are our critical points where the first derivative is equal to 0, then you can see that it's going to be positive on the left because g prime of x is greater than x, whereas here it starts to invert, right? The g prime of x is less than x, so that means g prime of x minus x is less than 0, so that's negative. And then afterwards, it still stays negative, right? Because g prime of x is going to be below that line, so it's going to be negative here. So you can see that we switch from positive to negative at rad 2. What does that make it? That makes it a relative max. Whereas at 3, it doesn't switch from anything, it goes from negative to negative. So that is going to be neither a max nor a minimum. And that's going to be our answer for part C. Any questions here? Okay, could take a look at the next problem. Probably the last one that we do today. Alright. So solutions to the differential equation dy dx is equal to xy to the third also satisfy this here. Let y equals f of x be a particular solution to the differential equations with f1 is equal to 2. So they want us to first write an equation for the tangent line to the graph of y is equal to f of x at x is equal to 1. Alright. So to write a equation for a tangent line, we're going to need a point. We know our point is going to be f of 1 is equal to 2, so that's going to be 1 comma 2. And we also need a slope, and the slope is going to be dy dx when we plug in 1 comma 2, so that's x is equal to 1, y is equal to 2. So that's going to be 1 and 2 to the third. That's going to be equal to 8. So when I have my point, I have my slope. Equation of the tangent line is just like this here. Don't really need to modify it because this is the equation of a line already, although you can really write it in whichever form you like. I just personally don't see a reason why you would change it from this. Okay, next it says use the tangent line from part A to approximate f of 1.1. Given that f of x is greater than 0 for 1 to 1.1 is the approximation for f of 1.1 greater than or less than of f of 1.1. Explain your reasoning. Okay, so there's several parts here. First, we need to find our approximation, right? And then after that, then I'll start to consider the second part. So how do we approximate this? For a line, you might find it actually a little bit beneficial to modify the form just a little bit. You can write it as y is equal to 2 plus 8 times x minus 1. And this way it's just a little easier to just plug in 1.1. You can say f of 1.1 is then approximately 2 plus 8 times 1.1 minus 1, which is going to be 2 plus 8 times 0.1. That's going to be 2.8. So f of 1.1 is approximately 2.8. Next, it's asking you is this greater than or less than f of 1.1? And to do that, we need to understand the concavity, right? Because if, for example, your shape looks like this, where it's concave up, where we have like x equals 1 here, this is 1 comma 2, and then this is 1.1 comma something, which is what we're trying to approximate, right? If it's concave up, then you can see our linear approximation is going to be a underestimate, right? Because it's under here. But if it's concave down, then it's going to be an overestimate, as you can see with just this rough diagram, right? So we need to understand what the concavity is. So why don't I go ahead and plug in my values. Let's plug in 1 comma 2 into the second derivative and see what happens. That's going to be 2 to the third, 1 plus 3 times 1 squared times 2 squared. So that's going to be 8 times 4, 12, 13. And that's positive, right? So that means it's concave up. So we have this concave up scenario. And that's it, right? So we already made that conclusion that if it's concave up, it's going to be less than, right? So we're going to say that our approximation is less than the true value of f of 1.1 because our function is concave up and the tangent line lies below the curve. At 1.1. Oh, you want me to do worksheet 98 number 8? I can do that. Sorry, I just saw that, so I'm not entirely sure when you sent it. Oh, you sent it 6 minutes ago. Okay, so probably before I started this problem. I'll do that now. Okay. So you said worksheet 98, number 8. Find the y-intercept of the line tangent. Okay. So we first have to find the slope of the tangent line, right? And to find the slope of the tangent line, that's going to be the first derivative, right? dy dx. So the question is, how do I differentiate this? There's a product rule and a chain rule, right? So product rule first, I have this times that. So product rule tells me I have x cubed minus 4x squared plus 8 times the derivative of the second part. The derivative of the second part is e cosine of x squared times the derivative of cosine of x squared. Derivative of cosine of x squared is going to be negative sine of x squared. And derivative of x squared is going to be 2x. So that's chain rule, right? So derivative of the e to the x part is just itself, and the derivative of the inside is negative sine of x squared, and derivative of the x squared. This here, since there's no parentheses, that squared is belonging to the x and it's inside the cosine. And then we need to add that with third of the first part, that's going to be 3x squared minus 8x, and then times just the second part. So this is our slope. Is there even anything we can do here? I mean, probably just plug in 2 now, right? It doesn't really look that nice. So if I plug in 2, what can we do? We can say that's going to be 8 minus 4 times 4 is 16, and then plus 8. So that's a 0, right? So that actually makes this whole thing 0. And then, so I don't even need to finish the rest of it, right? And then I have this plus. So this whole thing becomes 0. And then this one is what? That's 3 times 4. That's 12 minus 16. E to the cosine of 4, right? X squared, 2 squared is 4. So that's going to be negative 4 e to the cosine of 4. So this is our slope for our tangent line. And then, so I have my slope. Just going to write an m as slope. And I'm going to need a point, right? I don't have this point, but I can find it by plugging in x equals 2 into just the y value, into the y function. That's going to be 8 minus 16 plus 8 times e to the cosine of 4. And again, this whole thing is 0, so our y value is 0, so that means our point is 1, 0. So our function of our line then is y minus 0 is equal to our slope times x minus 1. That's y is equal to negative 4 e to the cosine of 4 times x, and then plus 4 e to the cosine of 4. So this here is going to be our y-intercept. So the y-intercept is 0, 4 e to the cosine of 4. Oh, x is equal to 2, yeah. I don't know where I wrote this, where I got this 1 from, but yeah, it's 2. Thank you. So this should be a 2 here, and this should be a 8. Yeah, that's weird. Thank you. 8e to the cosine of 4 is going to be 4.161 as a decimal. All right. That's probably going to be the last one I'm going to do. Can't really stay much longer than this. I didn't get to finish the entirety of number 6. There's still one more part. It asks you to, I mean, I'm sure if you like just open the link, it'll show you what the question is. It says find the particular solution of that differential equation, and you know already how to solve differential equations, right? You separate your variables and just integrate both sides. Nothing too complex. I think the questions that I answered were already a little bit more, I guess the word is, I want to say it's just interesting because they're not so straightforward of a question, right? So you kind of have to think about what everything means to answer these questions. Yeah. Although this first one was kind of straightforward, you just use the formulas. Anyways, hope this was helpful. If you guys have any other questions, I mean, you know how to reach me, right? So you can like message me tonight or something, and I'll probably respond. But yeah, just gonna end here. Thanks for coming. Yeah, I'll see you guys next time.